Okay, today we're in section 3.4, which is solving inequalities using addition or subtraction. And I know we've just kind of got used to solving big equations and things, and we're moving to a different thing, but it's basically the same thing. An inequality is basically an equation, except without instead of an equal sign, what we have is a less than, greater than, greater than or equal to, or a less than or equal to sign between the two expressions. So we have four different possibilities with inequalities, whereas with an equation, it was just an equal sign. But we're going to get into that a little bit today, and we're going to learn what that means and how we can solve inequalities. And it's basically, again, it's basically the same as equations. So, except with our solving of inequalities, we're going to have a graph. So we're going to use a number line to show our solution. And also with inequalities, you generally have a bunch of solutions, not just one. With an equation, you have one solution or no solutions or an infinite number of solutions. Those are your three choices there. But with these, with inequalities, you have an infinite amount of solutions every time. And you'll see that as we go along. But solving is not hard. So stick with me. Let's look at what an inequality is. It's a statement formed by placing an inequality symbol between two expressions, and I think I've already said that. Okay, so you've got two expressions, you put a greater than sign, less than sign between it, you've got an inequality. Okay, a solution of an inequality with a variable is the set of all numbers that produces true statements when substituted for that variable. So if I've got x is less than 3, and let's look at this first one right here. I thought I had this down. Good. So here I've got x is less than 3. Well, what makes that true? Well, 2 does. 1, 0, anything less than 3 makes that true. Okay, so a solution for this would be anything that makes it true. Okay, and let's show you how we're going to graph that. If I've got x is less than 3 as a solution, I'm going to, on my number line, I'm going to find the number 3, and I'm going to circle it. Okay, now all the numbers less than 3 go to the, are on the left here. And so from here, from this point, and this can be a little rough because I'm just kind of freehanding, I'm going to have a line going this way with an arrow. And what that says is that every number less than 3 is a solution for this inequality. Okay, that's just what the graph says. Look at the number, the next one, all numbers greater than 3. Again, find the 3 and circle it. Again, the 3 is right here. It's part of my solution. Okay, it's not actually part of the solution, but it's in the, after we solve, we will have this number right here. That's what we're always looking at on our number line. Okay, greater than 3, well, that's all the numbers to the right, because those numbers are bigger than 3. So my arrow goes this way. Okay, now let's look at this one. All numbers greater than or equal to, this little line means it can also be equal to. So that means 3 is a solution because 3 is greater than or equal to. Well, it's equal to, but it's one or the other. And so 3 is actually a solution with this one. 3 is not a solution here because 3 is not less than 3. But when I put an equal to sign with it, it is part of the solution. So we graph that a little different. I'm going to circle the 3 again, but because it is part of the solution, I colored the circle in. So anytime I have a little equal sign here, I'm going to color the circle in. Greater than goes to the right. Well, my line went up. It's not supposed to, but that's pretty bad. The next one, x is less than or equal to 3. Again, circle it. Because it has an equal sign, it includes the 3. So when I include the 3, I want to color it in. And going less than is left. So I want to make sure my arrow is going to the left. Okay? Now let's look at some problems that we have to solve. Again, very basic. We're actually going back to the beginning solving these problems. But here, again, I want to get x by itself. And I'm going to solve this just as if this was an equal sign here. Okay, so I want to get x by itself. And I may even draw my little line down like I normally do. I'm going to subtract 5 from both sides. Okay, so x is greater than or equal to 5. Okay, easy, one step. Okay, but I want to graph that. And here's what you're going to have to do on your paper. Underneath, okay, now take this here. You got the number 5 there. So in the middle of your graph, just put the number 5. On this side, put one number. And on this side, put one number. So I want to see 3 numbers on your graph, okay? So in this one, I've got one number bigger, one number smaller. Okay, I am going to circle the 5. Do I color the 5 in? Well, yes, just color it circle in because I've got an equal sign there. So that means the answers include the 5, and x is bigger than that, so bigger goes to the right. And that's what hopefully yours looks a little better than that, but I am having a hard time with this tablet. Okay, on this one, let's solve for x. Okay, again, I've got this. I'm going to add 12 to both sides because I want to get rid of the negative 12. I get 2 here. Okay, now this says x is greater than 2. Okay, so you may flip it around like this. X is greater than 2. Notice it points toward the 2. It still points toward the 2 when I flip it around. And I say flip it around because a lot of people mess up if they don't flip it around. Okay, got a short number line here. Got a 2 in the middle, so that's what we found here. Got a 3 here and a 1 here. I'm going to circle the 2. Do I color the 2 in? No, I don't, because there's not an equal sign. So 2 is not included in the solutions. X is bigger than 2, so bigger numbers are to the right, going to the right, and I'm done. Let's look at this one. Subtract 7 from both sides. I've got x is greater than negative 4. Okay, again, number line. And I've got a negative 4 in the center. Okay, on this side I've got negative 3. Remember, we're getting bigger on the negative side, so that would be negative 3, and this is negative 5. Okay, I'm going to circle the negative 4. Do I color it in? No, there's not an equal sign, so I don't. And it's bigger than. X is bigger than numbers are going this way. Anything bigger than negative 4 is this way. Okay, let's look at the next one. Oh, got a little mark there. Subtract 4 from both sides. I get 6 greater than or equal to y. And I probably want to turn that around. That looks like a 4, it's a y. So y is less than or equal to 6. Remember to, if you turn the thing around, remember to turn your sign around. Okay, again, I'm going to number line right here. I've got 6 in the middle of this thing. I've got a 7 here and a 5 here. Okay, I'm going to circle the 6, and it does have an equal sign here, so I want to color this in. That means 6 is included in the solution. Now, all the numbers less than or equal to 6, that's going this way. Okay, because 7 is not less than or equal to 6. They all have to be to the left. Okay, let's look at the next page. Okay, here, let's do a few here. I'm going to add 9 to both sides. I've got x greater than 3. I'm going to turn that around. X greater than 3. And if I graph that, my graph's going kind of crooked, but you'll get the idea. I put a 3 here. I'm going to put a 4 here and a 2 here. Okay, every teacher does the graphs differently. This is how we're going to do it now in my class. We're going to circle the 3. Now, it doesn't include the 3, so I'm not going to color the circle in, but it is bigger than 3, so it goes to the right. Let's do one more, and then we'll look at something else. Okay, I'm going to add 9 to both sides here, plus 9. I've got 10 greater than or equal to x. Well, let's flip this around and make it x less than or equal to 10. Okay, I'm going to graph this. I've got 10 here. I've got 11, and I've got 9. I'm going to circle, and I see that I have an equal sign there, so I have to color this in. And then x is less than, all the less than numbers are going to the left. It's a little squunched up, but you get the picture. Okay, so key words when we're looking at word problems are at least, at most, more than, less than, and greater than. That kind of tells you you've got an inequality for a word problem instead of an equation when you see these key words. Is an equal sign, but we don't see is in this list of keywords. We see at least, at most, more than, less than, greater than. Let's talk about at least. If x, let's look at x and 3. If x is at least 3, that means the question is, can x be 3 and that still be true? If I say x needs to be at least 3, can x be 3? And that be true? Yes. Can x be 2 and that be true? No. But x can be bigger than 3 and that still be true. So x is at least 3 would be greater than or equal to. What about at most? Well, if I look at x and 3, well, if x is at most 3, it can be equal to 3, but it can't be more than 3. So you have something like this. X is less than or equal to 3. Well, more than is pretty simple. If x is more than 3, it can't be equal to, it just has to be bigger than, something like that. Well, less than is less than, right? X is less than 3. And greater than is simply greater than, okay? That's what these keywords mean. It's very logical, but that's what they mean. Okay, let's look at the next page. Last page, in fact, we've got a word problem. You're competing in a triathlon, a sport competition with 3 events. Last year you finished the triathlon in 85 minutes. We're going to probably need this. This year in the swimming event, you posted a time of 17 minutes, while your time for biking was 45 minutes. So we got this, we got this. What possible times can you post in the running event and still beat last year's finishing time? So what possible times in the running event? So this X, that's our variable. It's our time in run event. Okay, so we've got to beat 85 minutes. Well, we can't be equal to 85 and beat 85. We got to be less than 85. So if this was last year's time, whatever this adds up to has to be less than that. Well, what do I have so far? I've got 17, and I've got 45. Okay, and then I've got whatever I do in the run event, which is X. Okay, and then I've just set up this very simple inequality from a word problem. Okay, so we've got 45 plus 17. That's going to be 62 plus X. And that's going to be less than 85. We're just solving. Okay, so we combine like terms right here. We added those together and we get 62. I'm going to subtract 62 from both sides. I get X is less than, let's see, 27. So the possible times I can get in the running event is anything less than 27 minutes. Okay, so 26.9999 minutes would work perfectly. 26, 25, anything less than 27 works. Okay, and that is my solution for this word problem.